Over the past year, the global media has been full of reports of catastrophic fires in California, the Mediterranean, Chile and elsewhere. One suggested reason for increases in catastrophic wildfires has been human-induced climate change. Higher temperatures, drier weather and windier conditions all increase the impact of fires. While climate change indeed raises the risk of wildfires, our research shows that another way humans can change patterns of fire activity is by introducing flammable plants to new environments. Read more: how will Canada manage its wildfires in the future? Plantations of highly flammable exotic species, such as pines and eucalypts, probably help to fuel the recent catastrophic fires in Portugal and in Chile. In arid regions, such as parts of the U.S. Southwest, the introduction of exotic grasses has transformed shrublands, as fires increase in severity. Invasive plants and fire. How do invasive plants change fire patterns? We burnt species mixtures, aka mixed grills, on our plant barbecue to help find out. Invasive plants are responsible for changing the patterns of fire activity in many ecosystems around the world. In particular, invasive species can lead to hotter and more frequent fires. Invasive plants can also reduce fire frequency and fire intensity, but there are fewer examples of this occurring worldwide. One of the main ways flammable invasive plants can have long-lasting impacts on an ecosystem comes from positive fire vegetation feedbacks. Such feedbacks can occur when a flammable weed invades a less fire-prone ecosystem. By changing the available fuel, the invader makes fires more likely and often hotter. If the invading species has characteristics that allow it to outcompete native species after a fire, then it will further dominate the ecosystem. Such traits include thick bark, the ability to resprout following fire, or seeds that survive burning. This invasion will likely lead to more fires, changing the species composition and function of the ecosystem in a fire begets fire cycle. Extreme examples of this dynamic are where flammable grasses or shrubs invade forests, leading to loss of the forest ecosystems. Mixed grills. We wanted to understand how invasive plants interact with other species when burned in combination. To explore the mechanisms underpinning such feedbacks, we examined how invasive plants might change the nature of a fire when burned together with native species. We collected 70 cm shoots of 4 globally invasive species, of both high and low flammability, and burned them in pairwise combinations with New Zealand native trees and shrubs to determine which characteristics of a fire could be attributed to the invasive plants. We found that overall flammability was largely driven by the most flammable species in the mixture, showing how highly flammable weeds could set in motion fire vegetation feedbacks. We established that a greater difference in flammability between the two species led to a larger influence of the more flammable species on overall flammability. This outcome suggests weeds that are much more flammable than the invaded community can have larger impacts on fire patterns.